All right, this is an experimental design and analysis related question, FRQ type 3 for Physics C and M. Students are investigating the relationship between the distance between two wires. I'll give you a gist of it. There are two wires, they are parallel to each other, but the current is flowing in opposite direction. With the current source that is not shown, there are power supplies that are not shown in the figure. And there is a force sensor that is placed near wire 2 so that it can measure the force acting on the wire 2. The distance between the two wires is d, right? That can be adjusted, of course, that can be adjusted. Now the question says that a student hypothesized that the force exerted by 1 on 2 is proportional to the inverse of the square of the distance between the two wires. So he said that the force acting between the two wires is inverse of the square of the distance. So what procedure can we use, what experiment can be used to determine the relationship between the magnitude of the magnetic force and the distance, include any steps that's necessary? So first I'm going to say, hope we know that the force acting between the two wires is given by mu naught I1 I2 length of the wire over 2 pi times the distance. So if I want to relate, obviously what this student hypothesized is incorrect, but what I want to highlight is you just want to change the force and the distance, right? All the other parameters should remain same. So what we want to say is, all right, the next is vary force sensor. We want to make sure that there is less uncertainty. So repeat the above procedure 3 times and note its average value. Then repeat steps rather 2 and 3 for different values of d. Yeah, tabulate force and 1 over d square. That's what we want to, after all, analyze, right? So that's how it works. Next, they are saying that what quantities are to be graphed and how the graph should be analyzed to test their hypothesis. So I want to graph force perhaps on y-axis and 1 over d square on the x-axis, right? And if the hypothesis is correct, force and 1 over d square, if they are proportional, it will result in a straight line. So I'm going to say that if graph is straight line, the hypothesis is correct. Otherwise, no. So that's how we can, well, conclude our hypothesis. All right, now they're saying that current and force are measured now, and the current is same in both the wires. That's what they are suggesting. And we are doing all this experiment to figure out the value of mu naught. The length of the wire on which the force is acting is capital L, and capital L and D values are already given to us, and we found the values of F and I. So they are saying that what measurements could be graphed to get a straight line that can help us to figure out mu naught. So I'm going to borrow the same formula that I wrote earlier, that it should be mu naught I1 I2 L over 2 pi d. So I know that mu naught is just unknown. I1 I2 is same as I, so I square L over 2 pi d. And by the way, d is also same, right? Only the force and the current are changing. So if I want to make a graph between the force and the current such that the straight line can help me find the mu naught. So I think I should graph f and I square, right? So that f on y-axis and I square on x-axis, the slope will basically be the remaining thing that can help me to determine its value, right? So on the horizontal axis, I'm going to say that I will have I square, and on vertical axis, I will have F, or the force. We also have to figure out the values of I square, so I'll just write over here. So these are how the values would look like for I square. Next, they are asking us to plot these points and draw the line of best fit as well. So like I said, the y-axis is going to be force, and remember the unit of the force is millinewton. and the x-axis is going to be I square, and the unit is ampere square, so ampere square. 1, 2, 3, 4, 5, 6, 6 blocks in the vertical side, and the maximum value is from 0 to 1.1, I would say. So 1.1 or probably 1.5, let's call it 1.1. 1.1 over 6 is going to be 0.18. So I'm going to take every partition as 0.2. So this is how the y-axis looks like. And for the x-axis, so here we have the maximum value of 20. So 20, we have 5 partitions. So there you go, we have 4. So starting from 4, we have 4. This is how the x-axis looks like. So let's plot the points now. 2.8, 0.35. Sorry, 7.9 and 0.35. Let's so there are this is 4 units over 5 blocks. So 4 over 5 is 0.8. That's what corresponds to 1 block. So this will become 4.8. Then the next one will be 0.8, which is 5.6. Then again 0.8 will be 6.4, then 7.2, and then about 8. So we are looking for a 7.9, which is very, very close to 8. So that's going to look like 7.8, and 0.35 is, this is about right in the middle is 0.3. So 0.35 will be even in the middle. So this is the point that I'm looking for. Okay, that is the first point. These are the points. Obviously, doesn't look nice at all, but we are just going to draw a line of best fit, and I think a line of best fit probably should look something like this, I would say. Yeah, something like this. All right, now they are asking us to use the line of best fit with L and D values as given to find the value of mu naught. So let's take some nice points here to find the slope first of all. So nice grid intersection points. One is right here, I can see one is right here, and the other one is right here. These are my 2 points. So let's write the coordinates. This one will be 10.4, that's the x coordinate, because again these are partitioned by 0.8, and this is right over here. Here it's a 0.2 over 5. 0.2 over 5 is 0.04. So this is 0.44, 0.48, and this is 0.52 over here. So this point is 0.52. And likewise, this point over here is right here. So this is 12.8, this is 13.6. So this is 13.6, that is the x coordinate. And likewise, the y coordinate is 0.6, 0.64, 0.66, 0.72. So this is 0.72. So the points that we have are these two, and the slope is going to look like rise over run, which is 0.72 minus 0.52 over 13.6 minus 10.4. Comes out as 0.0625. And now I want to find the value of mu naught. I'm just going to borrow that slope from here. So let me just copy and take this over on that slide. So all I'm interested in is the slope value, which is mu naught L over 2 pi d, and that is equal to 0.0625. So if we isolate mu naught from here, that's going to look like 0.0625 2 pi d over L. Let's plug in the numbers. We can plug in the numbers, but we have to make sure what is the unit of slope, because slope is not Newton per ampere square. It's millinewton per ampere square. So you have to make sure that this milli factor is taken into account over here as well. So if you want to take that milli factor into account, you have to multiply this with 10 raised to negative 3. I mean, actually this one is 10 raised to negative 3, but I've just written it at the end. And if we find that, we will end up with 1.4 times 10 raised to negative 6 Newton per ampere square. So that is the value of mu naught, which is a pretty good value, because the actual value is 1.47. It's a pretty good value because the actual value is about 1.3 times 10 raised to negative 6, and this is 1.4. So that's a pretty good value.